On August 12, 2024, Yellowstone's wilderness awoke to something new. The first light of dawn revealed a subtle but extraordinary change in the landscape, one that would soon capture the attention of scientists and visitors alike. A park scientist making routine rounds spotted a thick, unfamiliar plume of steam rising from an ancient lava flow. The column twisted skyward, stark against the morning air, hinting at powerful forces at work beneath the surface. Geologists approached the site with a mix of excitement and caution, finding the ground unusually warm and a fresh fissure venting hot mineral-rich steam. The earth here seemed to pulse with energy, as if revealing a secret long kept. Instruments measured a blistering 171 degrees Fahrenheit, evidence of a direct link to Yellowstone's superheated underground system. The readings confirmed that this was no ordinary surface phenomenon, but a window into the restless heart of the caldera. This wasn't a sign of disaster but a vivid reminder: Yellowstone is alive, always changing. The land here is in constant motion, shaped by forces that have been at work for millennia. Scientists suspect this new vent connects to a thermal area first noticed in 2003, as underground channels shift and find new paths to the surface. These hidden networks of heat and water are always evolving, sometimes quietly, sometimes with dramatic flair. As winter arrived, the vent quieted, subdued by snow and meltwater. The landscape seemed to rest, but the silence was only on the surface. But this was only a pause. Beneath the frozen ground, the heat continued to build, waiting for its moment to return. Geologists watched, knowing the heat below remained. Their instruments and careful observations told them that Yellowstone's story was far from over. With spring's return, the vent is expected to reawaken, its steam a heartbeat of the Yellowstone caldera. The cycle of dormancy and renewal is part of what makes this place so extraordinary. Each new feature is a reminder of the immense power just beneath our feet. The earth here is never truly still, always shifting, always surprising. Yellowstone is not a static monument but a living, breathing landscape. Its beauty lies in its unpredictability, its ability to transform before our eyes. Its story is still being written, one vent at a time. And as long as the earth moves beneath Yellowstone, there will always be new chapters to discover. For years, scientists tracked Yellowstone's earthquakes, braving the elements to set up sensitive instruments across the park's vast, untamed wilderness. They listened to the ground's subtle tremors, recording every shake and shudder, hoping to decipher the secrets hidden beneath the surface. Believing they understood the park's seismic activity, they mapped out patterns and cataloged thousands of quakes, confident in their grasp of Yellowstone's restless nature. But in 2025, a breakthrough changed everything. Artificial intelligence revealed a hidden world beneath the surface, one that had eluded even the most experienced researchers. Researchers trained advanced AI systems to detect the faintest seismic signals, tiny whispers in the earth that human eyes and ears had missed for decades. The AI could sift through mountains of data, finding patterns invisible to traditional analysis. The AI analyzed 14 years of continuous seismic data, discovering over 86,000 previously undetected earthquakes, 10 times more than scientists had ever known before. Each new quake was a piece of a much larger puzzle. It was like seeing a star-filled sky for the first time, where once there had been only darkness. Suddenly, the Earth's hidden rhythms became visible, a cosmic dance beneath our feet. This seismic revelation gave scientists a detailed map of the stresses and movements deep below Yellowstone, illuminating the intricate web of faults and fractures that shaped the land. Each tiny quake is a clue, revealing the hidden pathways of fluids and the subtle shifts in the magma chamber. These micro-earthquakes help scientists trace the journey of heat and pressure as it moves through the Earth. With this new data, scientists can better understand the volcano's inner workings, predicting how it might behave in the future and how its energy shapes the landscape above. The hidden symphony of Yellowstone's earthquakes is now coming to light, transforming our view of this dynamic, ever-changing world. AI has transformed our understanding of this restless giant, giving us tools to listen more closely to the Earth's quiet conversations. The Earth is far more talkative than we ever imagined, and with every new discovery, we are reminded that there is still so much more to learn from the whispers of this hidden world. The AI's most striking discovery was the prevalence of earthquake swarms, clusters of small quakes, not isolated jolts. These swarms are not just random, they reveal a hidden rhythm beneath Yellowstone, a pattern that was once invisible to the human eye. Instead of a single, dramatic quake, the ground pulses with dozens, sometimes hundreds of tiny tremors, each one a clue to the restless forces below. These swarms, like rapid-fire bursts, are signatures of fluid moving through Yellowstone's jagged underground faults. The earth here is alive with motion, as water and gas surge through fractures, creating a symphony of seismic activity that often goes unnoticed by visitors above. Hot water and gases heated by the magma below force their way through cracks, sometimes triggering cascades of tiny quakes. Each bubble and hiss at the surface is connected to a much larger, dynamic process deep underground, where heat and pressure are constantly at play. The AI's detection of these micro-earthquakes lets scientists map Yellowstone's underground plumbing in unprecedented detail. By tracking the swarms, researchers can visualize the hidden pathways that water and gas travel, revealing the complex network that fuels Yellowstone's famous geysers and hot springs. This is crucial, because the movement of water, steam and gas drives geysers and influences the pressure on the magma chamber. Even small changes in this underground system can have dramatic effects on the surface, shaping the landscape and the timing of eruptions. Understanding swarms is like reading the volcano's circulatory system. Each tremor is a pulse, a sign of life and change, helping scientists decode the signals that precede larger events. This knowledge helps assess hazards not just at Yellowstone but at other volcanic and geothermal sites worldwide. The lessons learned here are shaping how we monitor and respond to volcanic threats across the globe. By studying these patterns, scientists can better forecast seismic activity. Early detection and understanding of swarms could one day provide vital warnings, protecting both people and the environment. Yellowstone's chaotic swarms are teaching us the universal language of the Earth. Each sequence of tremors is a story, a message from the planet's fiery heart. Each tremor is a message from deep below, a whisper from the magma and water that shape this land. The more we listen, the more we learn, and the better prepared we become for what the Earth might reveal next. Yellowstone's ground is always moving, rising and falling in a slow, steady rhythm. This ground deformation is a vital sign tracked for over a century. Between 2004 and 2009, the caldera swelled by nearly 10 inches, pushed up by new magma intruding below. Since 2010, the ground has slowly subsided as pressure is released and magma cools or escapes as gas and steam. This breathing motion is normal for a living caldera. Scientists use GPS and other sensitive instruments to monitor these subtle changes. By combining ground movement data with earthquake and gas readings, they build a comprehensive picture of the volcano's health. Constant monitoring is our early warning system. Yellowstone's gentle breathing is a sign of life, not imminent danger. The caldera's pulse continues, steady and watchful. Yellowstone's peaceful scenery hides a violent past. Over 2.1 million years, 3 super eruptions shaped this land, each one a planetary-scale event. The last, 640,000 years ago, ejected over 1,000 cubic kilometers of material, blanketing North America in ash and cooling the planet. The ground collapsed, forming the vast caldera we see today. Since then, activity has been quieter, occasional lava flows, the most recent about 70,000 years ago. These flows, not explosions, are the norm between super eruptions. Despite new vents and hidden quakes, there's no sign of an impending super eruption. The Yellowstone Volcano Observatory reports low unrest and dormancy. Any major eruption would be preceded by decades of dramatic warning signs, none of which are present. Yellowstone's story is one of long calm, punctuated by rare, extraordinary events. Today, the giant sleeps. If not a super eruption, what's next for Yellowstone? The most likely events are hydrothermal explosions, violent bursts of steam and hot water when underground channels get blocked. These explosions can create craters and reshape the landscape, but their effects are local. Lava flows are also possible but would move slowly and remain within the caldera, posing little risk beyond the park. Yellowstone's typical activity is far less dramatic than its ancient eruptions. The Yellowstone Volcano Observatory's network of sensors provides early warnings for any changes. Scientists watch for earthquake swarms, ground swelling and gas shifts, signs that fluids or magma are on the move. Vigilance ensures public safety and keeps Yellowstone's story unfolding safely. Yellowstone is more than a volcano. It's a window into Earth's inner workings, revealing secrets hidden deep beneath the surface. Every new quake, vent, and shift adds to our understanding, offering fresh clues about the forces shaping our world. AI and advanced monitoring help us distinguish normal activity from warning signs, making our observations more precise than ever before. This research protects not just Yellowstone but communities near volcanoes worldwide, ensuring people can live safely in these dynamic regions. Studying Yellowstone teaches us about mountain building, mineral formation, and geothermal energy, expanding our knowledge of Earth's processes. The discoveries here have global impact, guiding sustainable development and safety for future generations everywhere. Yellowstone's restless beauty reminds us that our planet is alive and ever-changing, full of wonder and possibility. By listening to its whispers, we deepen our connection to the living Earth and learn to respect its incredible power.